Footage from PLA state television showed the 72nd Group Army, China's primary force for Taiwan Strait operations, conducting an amphibious landing drill that most analysts had never seen in real operational footage before. Four-legged robot wolves, 70 kilograms each, equipped with assault rifles and 5 cameras for 360-degree awareness, sprinting across a simulated beachhead ahead of human troops, exploding through barbed wire, clearing obstacles, absorbing fire, getting destroyed, and being replaced immediately by the next wave. One soldier controlling 9 wolf robots and 6 drones simultaneously through a real-time 3-dimensional battlefield interface. Time from target detection to destruction, under 10 seconds. The combat radius of a standard infantry squad expanded 4 times. The PLA called this exercise a showcase of intelligent sea tactics. The era of human wave tactics, they said, is over. I want to walk you through what this footage actually reveals about the future of the Taiwan conflict, using structural history, game theory, and the specific military logic that Taiwan's deterrence calculation has always depended on. Because the mainstream coverage of this story is focusing on the robots themselves. The structural analysis requires focusing on what the robots do to Taiwan's assumptions. The global order is shifting faster than the news cycle can report. Hit subscribe to stay ahead of the curve, because what I am about to show you changes everything. Let me start with the deterrence math, because understanding why the current calculation worked is the only way to understand why robot soldiers break it. Taiwan's defense strategy has always been built around the concept of asymmetric deterrence. Taiwan cannot match China's military in scale. China has the largest active military force in the world. Taiwan cannot win a conventional war of attrition. What Taiwan can do, and what its entire defense posture is built around, is make a Chinese invasion so costly in human terms that Beijing calculates the price is too high to pay. The logic works through a specific mechanism. An amphibious assault is the most dangerous military operation in existence. You have to move troops across open water and slow-moving vessels against a prepared defender who knows exactly where you are coming from and has positioned weapons to kill you at the waterline. The historical casualty rates for amphibious assaults are staggering. At Tarawa in 1943, the United States took more than 3,000 casualties in 76 hours. At Omaha Beach, American forces suffered more casualties in the first 30 minutes than in the entire North African campaign. Taiwan's deterrence relies on this math. If China needs to send 100,000 human soldiers across the strait to establish a beachhead, and Taiwan can kill 10,000 of them at the waterline before they reach shore, the political cost to Beijing of that operation becomes potentially prohibitive. Xi Jinping faces the same domestic political constraint that every leader of a major power faces. The population will accept casualties for victory, but not for an operation that looks like a catastrophic failure. Dead soldiers, filmed and documented, create political pressure that even authoritarian governments cannot fully suppress. Russia's experience in Ukraine has demonstrated this even for systems far more insulated from public opinion than China's. Keep that specific mechanism in the back of your mind because the wolf robots attack it directly. The first structural force is what I call the casualty decoupling. The wolf robots are not designed to replace human soldiers in every function. They are designed to replace human soldiers in the most dangerous function, the first wave of an amphibious assault, the beachhead clearance, the obstacle removal. The initial exposure to defender fire that historically produces the catastrophic casualties that make amphibious assault so politically costly. Think about what this means for Taiwan's deterrence logic. Taiwan's anti-ship missiles can kill landing craft. Taiwan's shore artillery can fire at the beachhead. Taiwan's infantry can engage troops at the waterline. All of those capabilities remain. But the targets of those capabilities in the first wave are no longer Chinese soldiers. They are machines that cost, by current estimates, somewhere between $50,000 and $200,000 each. Not $200,000 worth of political cost to Beijing. $200,000 worth of manufacturing cost. A Chinese soldier killed on a Taiwan beach is a photograph, a grieving family, a domestic political problem. A wolf robot destroyed on a Taiwan beach is a line in a procurement budget. The deterrence math does not simply change, it inverts. Taiwan's most effective defenses, the ones that impose the human cost that were supposed to deter the invasion, become less effective against the first wave precisely because the first wave does not consist of humans. The second structural force is the production equation. China is the world's largest manufacturer of industrial robots. This is not a military statistic, it is an economic one. China installed more than a third of all industrial robots deployed globally in 2024. Its robotics manufacturing capacity, built to serve automotive, electronics, and logistics industries, is the same industrial base that produces the Wolf robot platforms being fielded by the PLA. This matters strategically for a reason that is easy to miss. Military equipment is normally constrained by specialized production lines, rare materials, and highly skilled labor. You cannot scale the production of a fighter jet the way you scale the production of a smartphone. But a quadruped robot platform is in its fundamental engineering much closer to an industrial machine than to a fighter jet. The same factories, the same supply chains, the same manufacturing processes that produce robots for Chinese warehouses and assembly lines can be adapted to produce Wolf robots. Consider what that means in practical terms. A semi-marathon in China earlier this year saw a robot complete the course ahead of human competitors. That robot was not a military system, it was a commercial humanoid platform produced by a consumer robotics company. The engineering advances that made that achievement possible, improved balance algorithms, more efficient actuators, better terrain recognition, are directly transferable to military quadruped platforms. China is not developing military robots in a separate technological silo from its commercial robotics industry. The two are feeding each other in a development cycle that accelerates both. The PLA's current doctrine describes the Wolf robots as attritable systems, meaning designed to be destroyed and replaced. This is not a weakness in the system. It is the point. Expendable robots change the economics of warfare the same way that cheap first-person view drones change the economics of the Ukraine conflict. When your weapons cost $100,000 and your enemy's weapons cost $500, the enemy can absorb far more losses than you before the balance tips. Ukraine demonstrated that a $50,000 drone can destroy a $3 million main battle tank. The Wolf robot applies the same logic to amphibious assault. A $200,000 machine absorbing fire that would have killed a soldier does not generate a grieving family, a viral photograph, or a domestic political crisis. It generates a parts order. Now I want to go deeper because this is where most people's analysis completely breaks down. The third structural force is the hellscape problem. Taiwan and its American backers have developed a counter strategy to Chinese amphibious invasion that military planners call hellscape. The concept is built around the idea that Taiwan can make the strait itself into an impassable killing ground using a combination of naval drones, aerial drones, smart mines, and coordinated fires that saturate any Chinese landing force with simultaneous attacks from multiple directions. The hellscape concept was designed to defeat a human amphibious force. Its core mechanism is the same as Taiwan's traditional deterrence. Impose casualties faster than the attacker can sustain them politically. Dense drone swarms attacking landing craft. Anti-ship missiles targeting support vessels. Shore fire cutting down troops at the waterline. The Wolf robot changes the calculus of hellscape in a specific way. The concept's effectiveness depends on the first wave casualties being politically meaningful to Beijing. If the first wave is robots rather than soldiers, the hellscape attrites machines rather than people, machines that can be replaced, machines that do not generate the domestic political pressure that hellscape was designed to exploit. This is not a hypothetical concern. The Center for a New American Security published a detailed analysis of the hellscape concept in February 2026. The report noted explicitly that the rise of Chinese robotic systems creates what the authors called an adaptation cycle. Taiwan deploys countermeasures. China deploys countermeasures. The cycle accelerates. The report recommended that Taiwan develop more aggressive counter-drone and counter-robot capabilities, specifically because the emergence of attritable robotic first-wave forces undermines the foundational assumptions of the asymmetric deterrence strategy. Taiwan's parliament to date has blocked the budget for the TDOM integrated air and missile defense network that President Lai Ching-te proposed, specifically to address the drone and robot threat. The opposition has proposed budgets that omit this funding. Taiwan's countermeasure to the problem the wolf robots create has been blocked by Taiwan's own political process. Real families in Taiwan are watching this footage and asking a question that their government has not yet answered. What happens to our coastal defenses when the things hitting our beaches cannot be killed in a way that matters politically to Beijing? Now, most people watching this story would say, but the wolf robots have significant limitations. The footage from the PLA exercise showed robots being destroyed by relatively light fire. One was shot down by a single defender during the drill. They are thermally conspicuous. They are slow on open terrain. They lack protection against fragmentation. Their communication links can be jammed. For all the dramatic footage, these are not autonomous killing machines that can operate independently in complex combat environments. They require human operators. They fail in ways that unprepared soldiers do not. And they represent a technology that is developing rapidly but is not yet mature. This argument is correct about every individual limitation, and it completely misses the structural logic. Here is the reality. The limitations of the wolf robot in 2026 are almost exactly the limitations of the armed drone in 2015. In 2015, military analysts cataloged the weaknesses of combat drone systems at length: limited range, vulnerable to jamming, unable to operate in contested airspace, dependent on reliable communication links, too expensive to be truly expendable. 7 years later, cheap FPV drones equipped with commercial components were destroying main battle tanks in Ukraine. The technology matured faster than the limitations-focused analysis predicted because the incentives driving development were enormous and the production costs were falling. The wolf robot is on the same trajectory. The 72nd Group Army's exercise was not the endpoint of Chinese robotic military development. It was the public showcase of a system that is already being refined. The PLA's Eastern Theater Command has been conducting increasingly sophisticated robotic integration exercises since 2023. Each exercise reveals limitations. Each limitation produces a development response. The time horizon for the wolf robot to transition from tactically interesting to strategically decisive is not decades, it is years. The historical parallel that illuminates this trajectory is not a military one, it is industrial. In 1908, Henry Ford introduced the Model T. Automotive critics cataloged its limitations extensively. It was unreliable in cold weather. It required significant mechanical knowledge to operate. It could not handle unpaved roads, which in 1908 described most roads in the world. It was a curiosity that serious transportation experts did not believe would replace the horse. 12 years later, Ford was producing more than 1 million Model T vehicles per year. The horse-drawn transportation network that had existed for centuries had been structurally displaced. Not because the Model T of 1908 was better than a horse in every condition, because the manufacturing trajectory, driven by scale and incentives, produced a technology that improved faster than any critic's catalog of limitations could keep pace with. China's wolf robot is the Model T of robotic warfare. What matters is not the current specification sheet. What matters is the direction of the trajectory and the capacity of the manufacturing base that is driving it. Watch 4 things in the coming months. The first thing to watch is the frequency and sophistication of PLA amphibious exercises that integrate robotic systems. The October 2025 exercise was a public showcase. It was not the only exercise. Watch whether state media releases footage of increasingly sophisticated integration, larger numbers of robots per unit, and more complex coordination between robotic ground systems and aerial drones. Each release is a deliberate signal to Taiwan and to the United States about where the capability sits on its development curve. The second thing to watch is Taiwan's defense budget. President Lai has proposed the T-Dome air and missile defense system specifically to address the unmanned threat. The opposition has blocked it. Watch whether the wolf robot footage changes the domestic political calculus in Taipei. A parliament that refuses to fund counter-robot defenses after publicly available footage of robot amphibious assault drills is making a strategic bet that the technology will not mature quickly enough to matter. That is a bet with very high stakes. The third thing to watch is American counter-robot development. The United States military has been conducting its own experiments with armed quadruped platforms. The Army has tested weapons-mounted robot dogs in limited exercises, but the scale and pace of American development is significantly behind Chinese deployment. Watch whether the Department of Defense accelerates funding for counter-UGV capabilities, specifically in the context of Taiwan contingency planning. The CNA's Hellscape report recommended exactly this. Whether it translates to procurement will tell you how seriously the American defense establishment is taking the threat. The fourth thing to watch is how China presents this technology to its own domestic audience. The Wolf robot footage was broadcast on CCTV, China's official state television. That is not an accident. It is a deliberate communication to the Chinese public that the PLA is developing capabilities that reduce Chinese casualties in any Taiwan operation. This matters for domestic political reasons. An invasion of Taiwan that costs 100,000 Chinese lives is a political risk for Xi Jinping. An invasion that is led by robots, with human soldiers following once the beachhead is secured, is an easier political sell domestically. Watch whether Chinese state media coverage of robotic military systems emphasizes casualty reduction as a narrative theme. The structural conclusion from all of this is not that China will invade Taiwan this year, or next year, or necessarily in this decade. The structural conclusion is more specific. The deterrence calculation that has kept the Taiwan Strait stable for decades was always built on a specific assumption that the cost of an amphibious assault in human terms would constrain Chinese decision-making. That assumption is now being systematically addressed by a technology that is developing on a Chinese manufacturing timeline, not a military procurement timeline. And the thing about a manufacturing timeline is that it is very fast. Taiwan is not undefended. Taiwan's military is capable, well-trained, and increasingly equipped with asymmetric weapons designed for exactly this threat. The United States maintains its security commitment, however ambiguously under the current administration. The Taiwan Strait remains one of the most dangerous military flashpoints on Earth. None of that changes today. What changes today is the calculus. The Wolf robots that sprinted across that beach in October 2025 are not China's final answer to the Taiwan problem. They are China's opening move in a technological competition that will define the military balance of the most strategically important waterway in the world for the next decade. This is not prophecy. This is structural history combined with game theory. I might be wrong about the speed of Chinese robotic development. I might be wrong about whether Taiwan finds the political will and the resources to mount an effective counter. If I am wrong, we will come back and analyze why. Save this analysis. Come back in 12 months. Count how many Wolf robots appeared in PLA exercises. Check whether Taiwan's T-Dome budget passed. Check whether the American defense posture in the Pacific has adapted to the robotic threat. The answers will tell you whether the deterrence math is holding or whether it has already been rewritten in ways that the mainstream analysis has not yet caught up with. Subscribe if you want to follow this as it develops, because the story of China's robot army and Taiwan's defenses is the story of whether the rules of warfare that kept the Pacific stable for 50 years still apply. And the footage from October 2025 suggests they may not.